You guys know how nice it was in Malibu on Saturday?
Were you there?
I was there.
What the heck? Did you get into
Pepperdine BYU. Did I tell you guys I work for CBS Sports?
Yeah.
Yeah, so it was nice. It's just nice weather there. I was like, I'm not wearing a coat? I'm not used to that.
What's Pepperdine?
Pepperdine's a school in Malibu. They're in the West Coast Conference. They were leading at halftime. I'm surprised. Who's we? BYU did not play. Pepperdine.
Dang.
You're Tom. Sometimes the general is in you.
Yeah, BYU won, so. All right. Let's see here. So let's talk, by the way,
Yes.
okay? I think I told you earlier that you remember the formula A equals PERT, right?
Yes.
Okay? You can do this whole section mostly with that, okay? They give you a bunch of other stuff like doubles N naught E to the RT. Okay, it's the same formula. It's exactly the same formula. Okay, don't even worry about it. Just remember A equals PERT. It's easy. Okay, it's much easier to remember. Okay, so let's do one here. Okay, so a certain bacteria doubles every 3 hours. It's called coronavirus. No, just kidding.
Close.
Question. This is 4.6, yes. Okay. Initially, there is 1,000 in the colony. Okay. Find a model. Here, we'll do this in pieces. Okay. And I guess, it doesn't say that, but it's exponential. I mean, if it doubles every 3 hours, you can think of that as exponential growth, okay? So how would we figure this out? Okay? What is your principal? If we think of this as money, what's your principal?
1,000.
1,000, it's like $1,000, right? So it's going to 1,000 E, sorry, I need another zero there. E to your, what's your rate? Every 3 hours. No, your time is 3 hours, right?
2.
We don't know what the rate is.
I don't know.
I'm gonna leave that as R. What's your time?
3.
3 hours, so we don't care about months in this case. Okay? And it says, find a model. So all we know is a certain bacteria doubles every 3 hours. Okay? So in 3 hours, how many bacteria do you have? You're gonna have 2,000, right? Because it doubles. Okay? Now, this is not a function, but it's gonna help us figure out what the rate is, right? Okay? So how would we solve that, Natalie?
Well, first divide by 1,000.
Divide by 1,000, okay, so 2 equals E to the 3R. How do we solve that?
Take the natural log.
Take the natural log of both sides. So ln of 2 equals 3R. And then divide by 3. So rate equals the ln of 2 over 3. Now, if you can probably put that in a calculator, but here's what I'm going to recommend. If you want to put that in a calculator, that's fine. Use all the digits. Otherwise, you're going to get a rounding error, okay? I'm not going to worry about it. I'm just going to use that. That's my rate. It's ugly, but it's fine, okay? So if we find a model, and this is now my rate, and I want to find it how many bacteria have at any certain time t, what do I do, Fidencio?
Can you repeat the question, sorry?
I want to find a model, kind of like this, as a function of any time t. So, and this is the rate. So what's the model?
Um,
Do you need a hint?
Yeah.
It's going to look like that. Maybe I should put a function, a model function. That's what we're talking about. I want it in functional notation. In the book, they always use n for number of whatever,
right.
but I'm fine with a.
Then we'll put A equals
A of t, because we want
A
a
of
functional
t.
notation.
1,000
1,000, because that's what we started with.
E,
E,
then
ln of 2
ln,
over 3
times
times t.
T.
There you are. Okay, and in the book, they actually plugged in the calculator and they got a number of, I don't know. Actually, they didn't. They did it a different way. They gave you another formula, but what I'm telling you is if you don't want to remember a lot of formulas, just remember this one because it'll work. It works for everything. They actually have a formula that figures this out for half-life, but it's not worth remembering.
So what you're doing is you're figuring out the rate so you can plug in just about any time.
Okay? All right, let's go to part B. Part B says, how many bacteria in 15 hours? So, Caleb, it must be your turn.
So it'll be, A of 15 equals 1,000, E to the ln of 2 over 3 times.
Okay, and that 3 will cancel that, and that becomes just a 5. Either way, you can just plug it in your calculator, and you should get, if you do this right, 32,000, roughly. Okay? That's a lot. Yes?
Wait, can you do how you canceled out the ln so that you did
I'm only canceling the 3, not the ln.
Oh,
3 goes into 15 5 times. Okay? All right, part C says, when will it reach 100,000? One of the things you're going to find about this class, or this section, is it's going to get extremely repetitive. So, Chris, it must be your turn.
100,000.
100,000,
100,000 equals
1,000,
E.
E, ln of 2 over 3 times t, right? Okay, so those 3 zeros cancel those 3 zeros, right? Then what? He's asking for help, I can see. I said, I can see you're asking for help.
I don't know. The natural.
Take the natural log, because base E, right?
Yeah.
ln, so the ln of 100 equals the ln of 2 over 3 times t.
And then the natural you cancel out.
Nope. Is Derek your tutor? He is at the moment. Huh?
In A
It's Nate, that's the tutor? Okay, so what do we do next?
This tutor still has to learn.
Would you divide by the ln of 2/3?
But yeah, you can multiply by the reciprocal, right? 3 over the ln of 2, so those would cancel. 3 over the ln of 2. So that gives you t equals, now you can just plug that in your calculator. And if you do so properly, you should get 19.93 hours. So in 20 hours, you've got 100,000 bacteria. Okay? Does that work, Patrick?
I was just doing 10,000.
Oh, only said about 100,000.
Yeah.
Okay? Does that make sense? They give you a lot of equations, and all you need to know is remember this one. And it's all the same thing. Here, let's do another one. So this is exponential growth, but it also works for decay. Okay. All right. So let's say that polonium 210 has a half-life of 140 days. You start with 300 milligrams. Find the function that models mass after T days. Okay. Reagan, it must be your turn.
So the initial principle is.
Your principle is
300.
we start with 300 milligrams.
And we'll have E,
E,
and then rate,
the rate I don't know.
and then time is 100.
Okay, so 140 days is our half-life, right?
Yeah.
And so in 140 days, how much am I going to have left over? Half of 300, which is 150, right?
Yes.
Okay, so then how do I solve that?
So you can divide by 300.
Divided by 300. So that's going to be 1/2 equals E to the 140R.
And then you can take the natural log.
Take the natural log of both sides.
So then you
That's
have
going to pull out front. So we've got the ln of 0.5 equals 140R.
yes. And then divide by 100.
140. So your rate is the ln of 0.5 divided by 140. Okay? So we just figured out our rate. Now, let me ask you a question here for a minute. Is the ln of 0.5, is that positive or negative? Anybody know? Negative, because you plug it in the calculator, right?
Absolutely right.
Okay, do you know why? What's the ln of 1? 0. So anything less than 1 is going to be a negative number, right? Anything greater than 1 is going to be a positive number, okay? So this rate is actually a negative number because it is decaying. Oh, I didn't write the word decay, but half-life is decay. So you've got a negative rate here, which is what you want when it's decaying, okay? Now, we can take this information, you can plug it in your calculator if you do use all the digits, Otherwise, we're just gonna use this. And so, what is the model, Breezy? Since Reagan did most of the hard work there.
It's going to be, A to,
T, the functional notation, right? It's a function of time,
equals 300,
300,
E
E,
to the ln
5 over
40,
40
or sorry, T.
times T. Okay? They got a whole bunch of formulas in there. If you want to remember them, you're welcome to them, but that one works the best. It'll do it all, okay? There'll be one that it doesn't do. We'll do that one in just a minute. All right. Here, I'm just going to do part D on here. We're going to skip ahead because I want to make sure I have stuff for Newton's law of cooling. How long to get 200 milligrams left? And by the way, does anybody remember, do you guys remember a few years ago, well, it might have been 10, the Soviet guy who got poisoned by the Russians? I think it was polonium-210. Nasty stuff. But anyway, I can't remember. So this will kill you. No. But, so how long till you get 200 milligrams left? Must be Danae's turn.
Alright, so you start with 200
200
T.
equals what?
300 E
300
to the ln 0.5 over
1.5 over
140
140 times T. You're going to find these are super repetitive, okay?
divided by 300.
Divided by 300. So 2/3 equals E to the ln 0.5 over 140 times T. Take the natural log. So the natural log of 2/3 equals the ln of 0.5 over 140 times T. Solve for T by, actually you want to multiply by 140 and you want to divide by the ln of 0.5. So you can just do the reciprocal of that, right? Okay? And then I've got 140 over the ln of 0.5, which if you plug into your calculator, you should get part D says 81.9 days. Okay, about 82 days, you'll have 200 milligrams. Okay? Piece of cake? All right, the last one that I want to do, I'm going to have to rush through this one a little bit. There's only one type of problem that you won't use A equals PERT on, and it's Newton's law of cooling. T of T equals T sub S plus D sub 0 e to the minus KT. Okay? Now, oh, by the way, that looks like PERT, right? You see that that's PERT actually? Okay? Now, as far as these go, D0 equals your initial temperature. A temperature difference between an object and the surroundings. T sub S equals your surrounding temperature. Okay, and K is right. Okay, so the example is you got a cup of coffee at 200 degrees Fahrenheit is placed in a room temperature of 70 degrees. Now, I don't know why anybody's drinking 200-degree coffee. That will burn you badly. It will actually give you a 3rd-degree burn. You remember the woman who sued McDonald's because her 200-degree coffee burned her and caused 3rd-degree burns? There's a video. Those were nasty freaking injuries. It was horrible. Anyway, she sued McDonald's just saying, will you lower your freaking coffee? And they're like, no, we like to burn people. So anyway, stupid. After 10 minutes, coffee is 150 degrees, okay? So the idea here in this case is D sub 0, and I know we have to hurry on here, it's the temperature difference between the coffee and the room temperature, okay? So in this case, D sub 0 is going to be what? 130, okay? So your model, your temperature at time t is your surrounding temperature, which is 70 plus 130 times E, and I'm going to use R, your rate. We're going to have to figure out what that is. RT. So now we just need to figure out what the rate is, okay? So, sorry, I'm looking at the wrong one. Oh, we could figure that out because, okay, so this is your basic function, okay? We know after 10 minutes, the coffee is 150 degrees, okay? So 150 equals 70 plus 130, e to the minus r times 10 minutes, okay? So you can solve for r. I don't have time to do that, but at any rate, basically you just solve that equation. You guys are really good at that now, right?
Yeah.
We'll be by Thursday. By the way, we're having a test on Thursday. Okay. So it's a good thing I mentioned that. So as far as the homework goes, we've finished this basically. We've got a lot of story problems on here, but it's basically just plugging it in. Most of them are A equals PERT, but if you're doing a cooling, then it's slightly different. So we'll do 4.6 as the quiz tomorrow, then we'll do 5.1 Tuesday, we'll review Wednesday, we'll have a test Thursday. Okay, so see y'all tomorrow.